All right, so here is section 2 of chapter 7, and we're going to be factoring some more, but now we're going to be more specific about the form that we want. So we're going to be factoring trinomials of the form, and this is really important that you understand this form. It is ax squared, or I'm sorry, x squared plus bx plus c. So let me go ahead and just let me write this out again because I really want to drive home this this form that we have. So what we're looking at is x squared plus bx plus c. So in other words, the coefficient of the x squared term will always be a number 1, okay? So a long time ago, actually back in chapter 6, I had you go ahead and do an example like this. So if this is the problem and I said simplify, what I wanted you to do was go ahead and distribute. So you'd get x squared minus x plus 3x minus 3. And you would arrive at the answer x squared plus 2x minus 3. Now, if you're asking yourself, why am I showing you this? It's because if you notice, the answer that I came up with is a trinomial with, if you look at the coefficient out front of that x squared, it's a 1, which is exactly what we are looking at in this section in chapter 7. So in other words, if I'm giving you x squared plus 2x minus 3, so if this is given, then my question is going to be, okay, well, what were the two polynomials that you multiplied to get this? So what are the two polynomials that multiply to give x squared plus 2x minus 3? So if you think about this, we're going backwards again. Remember, it's kind of like Jeopardy. I'm giving you the answer. What you got to give me is the question. And the two polynomials are going to be very specific now. First, the two polynomials that we are looking at, and I'm writing this in red, they are both a binomial. So that's basically like the first idea. So, number 1, a binomial. Actually, let me write it like this. A binomial times a binomial will equal, now this is really important, it'll equal a trinomial, and I'm going to put this underneath, on most occasions. I can even spell the word occasion. I should have went with my gut. I think I'm right. On most occasions. Now, this isn't always the case. We're going to see special cases where we have a binomial times a binomial, and it actually equals another binomial, okay? All right, we'll see that, but we'll worry about that when we get there, okay? So the big question then becomes, all right, well, how do you do this, okay? In other words, if the directions are factor, x squared plus 7x plus 12, the question is, okay, well, how do we do this? Well, if you think about this, well, we have a trinomial, so the factored form of the answer has to be the multiplication of two binomials. We just saw that directly above. A binomial times a binomial equals a trinomial on most occasions, okay? So how do we factor this? Well, if you remember, and I'm going to go ahead and I'm going to do that problem again that I did previously. So I think it was x plus 3 times x minus 1. Notice that here I have a binomial times a binomial, and what I did is I underlined the first term in the first binomial, and I just distribute, okay? And I know when I take x and I multiply it times x, I have to get x squared, which is exactly what we're looking at up here in our problem. Therefore, and I'm going to write it in red, the first term in both binomials has to be the letter x, okay? Now, this is just me. You're not going to see this in any book. But I always copy down the first sign. I always copy it down no matter what it is. And then I think to myself and I say, okay, well, if I take this second term in the first binomial and I multiply it, or I distribute it to both terms in the other binomial, I know that, and I'm going to be real specific now, that this number right here that's already underlined at positive 3, and this number right here is going to give me that negative 3 if I multiply them together. In other words, and this is really what I'm concerned with, watch this. I know no matter what, for this example that I have down below, a positive times a negative will give me a negative number. Now, I can use that to my advantage, and here's how. I'm just going to erase all of this now. I know that my first number is going to be positive here. I also know that in my problem, that 12 is positive. So if I know that the first number is positive, then the second number has to be positive as well. Because if you think about it, a positive times a positive equals another positive. So now the only thing I got to be concerned with here is what two numbers multiply to give me 12 and then add to give me 3. And I'm going to write down these steps for you, so don't worry. So if I come over to the right-hand side, here's my goal. I'm going to write out the factors of 12. So 1 times 12, 2 times 6, 3 times 4. Okay? Now, these two numbers the chosen pair has to multiply to get 12 and add to get 7. So if you think about the pairs of numbers that I have up here, they all equal 12 if I were to multiply them. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. But now I need to make sure that they add, and maybe that's a bad word. Let's use the word combine. That they combine to give you 7. And here's the best part about this. If you look, I already know the signs of the numbers. The signs of the numbers are both positive because I already did that first. So if you think about it, since they're both positive, this is going to equal 13 if I add them together. Well, that's not good. Here, 2 plus 6 is going to equal 8. I don't want 8, I need 7, so I know that's not good. So my numbers, the chosen pair has to be positive 3 plus 4 equals a positive 7. And since these are both positive, it doesn't matter where you put them. And that's exactly how we factor a trinomial. So if you think about this, all right, and you go back and look at this example, we actually kind of have some steps going on here, all right? So let me go ahead and let me write down these steps for you. All right, so here are your steps here. I just copied and pasted them from my other class that I teach. So if you're factoring a trinomial of the form x squared plus bx plus c, the factored form is going to be down here in the following. So ax squared plus bx plus c is going to factor down into the multiplication of two binomials. Now, here's the key. These last numbers in the boxes, so let me highlight the boxes for you so you know what I'm talking about. So these last numbers in the boxes, they have to multiply so that it equals the number c, and they have to combine, even though it says sum, I like the word combine, to equal b. So step 1, you want to write the multiplication of two binomials. And what I mean by that is you always just want to do this. X and X. Okay? Step 2, you want to determine your signs for the binomial. Always copy down the first sign. So no matter what, you're always going to copy down that first sign, whatever it's going to be. In this case, I'm going to keep it very general and just put 2 plus signs, but they're going to be different. And then step 3, you're going to find the factors of the last term. And these factors should multiply to give you the last number, which is going to be C. So has to equal, let me write out the word. Got to equal C. And when you combine them, it has to equal whatever B is. Okay? So let me go ahead and do just a bunch of examples to show you how this works. So directions for all these are just going to be factor, okay? And I am just going to go right down the list here. So the first one is going to be x squared plus 11x plus 24. So step one, write the multiplication of two binomials with x's up front. Step two, we always copy down the first sign. Now this second sign and the second binomial, you're going to use, I'm moving way too fast here. The second sign and the second binomial is going to be determined by that right there that I have highlighted in yellow. So in other words, since the first one is positive and I know my answer is positive, a positive times a positive equals a positive. So both of these are going to be positive. Now we're going to write out the factors of 24, step 3. So we have 1 times 24, 2 times 12, 3 times 8, and I think 4 times 6. Now, our goal is to multiply to get 24. Well, we already established that by writing out the factors. But now I also need to combine them so it equals 11, okay? So we want these to combine to equal 11. And we know both numbers are going to be positive. So 1 plus 24 equals 25. That doesn't work. 2 plus 12, well, that equals 14. That doesn't work. 3 plus 8, well, that equals positive 11, and that works. Therefore, my answer is going to be x plus 3 times x plus 8. Or, if you wanted to, you can switch them if you want, because both signs of the 3 and the 8 are still both positive. Okay? So now what I want to do is I want to show you one where we have like negative signs. Okay? So here's an example here. Let's look at y to the second minus 9y minus, or no, we'll make it plus 18. So y to the second minus 9y plus 18. So once again, we're going to follow our steps. First step, we're going to write the multiplication of two binomials, and in this case, we're going to use the letter y. Step 2, I drop down the first sign, and here's what I know. I know this sign that I just copied times something has to equal a positive number. Got to be a positive number. So if you think about a long time ago, all right, and I'm going to write out this chart here to the right-hand side because I think sometimes we just forget about these little things. So if you write out your chart, a positive times a positive is a positive times a negative is a negative times a positive is another negative, and then the last row, a negative times a negative is a positive. So if your first number is negative, and your second, and your answer is positive, then you have to be in this fourth row. So your second sign has to be negative as well. So I'm going to go ahead and just put a negative in there. There we go. Now, let's find the numbers that multiply to give me 18. So it's going to be 1 and 18, 2 and 9, 3 and 6. And my goal is they have to combine to give you, and I'm going to highlight this, they got to combine to give us -9. Okay? They got to combine to give you -9. And the only way that's going to occur is right here. -3 minus 6 equals -9. So the 3 is negative and the 6 is negative. So I'll just put y minus 3 times y minus 6 and call it a day. Now, the next problem is going to be just a little bit different. Okay? Let me show you what I mean by this. We're going to factor z to the second plus 4z minus 5. Okay? Let me erase this. I'm going to come back to this table right here for this problem as well. All right, so here we go. It's a trinomial. It fits our form where the number in front of the squared term is a 1. So it fits our form. So we're just going to go ahead. We're going to write the multiplication of two binomials. All right, hopefully you're still with me here. And we're going to copy down the first sign. And here's what we know. Time to use the highlighter now. Get everything all nice and organized. The first sign is positive. The answer has to be a negative. So here is the row where my first number is positive and my answer is negative. Therefore, that second sign has to be a negative number. Okay? Got to be a negative number. Now, we need the factors of 5. Well, luckily for us, there's only one pair, 1 times 5. And this is why I like to do the signs first. Here's what I know. I know no matter what, these numbers have to combine to give me positive 4. And here's the best part. You already know one of the numbers is positive and the other number is negative. And the only way that I can use 1 and 5 together so that it equals 4 and I know one of them is positive and one of them is negative is -1 plus 5 equals positive 4. And because this is very specific, note that the 1 is negative, which means I need to put it with the minus sign in my answer. And the 5 is positive, which means I have to put it with a positive in my answer. So this turns out, and I'm just going to write it nice and neat. This turns out the factor form is z plus 5 times z minus 1. Now, I know a lot of us, back in the day, you were taught to write the binomials. You were taught this. Write the binomials, put the variable here, and then you were taught, go ahead and go right to the numbers. And then you had to worry about the signs later. And you were taught, well, if this doesn't work, when you check yourself, then just switch the signs and you're good. Well, that's an okay method as long as the problems are easy. As long as they're really simple. And I know you're probably sitting there thinking to yourself, if you've seen this before, you're probably sitting there thinking to yourself, boy, I remember a lot of times when I was doing this and I was constantly switching signs. And then I was constantly switching numbers. If you follow my technique, it's just switching to 2 steps, you're never ever going to have to worry about switching signs ever again. Because what you're doing is you're doing the signs first. Then you're using those signs to figure out what the numbers are. Okay? Let's try another one like this. All right, this time I'm going to kind of speed up a little bit. So here's our example. Oops, sorry. There we go. So here's our example. X squared plus x minus 20. So it's a trinomial. There's a 1 out front, so I know I can go directly into my multiplication of two binomials. Okay? So I'm going to write an x, and I always copy down the first sign. I know from my table above, if the first number is positive and the second number is negative, my second sign has to be a negative. Now, I'm going to write out the factors of 20, 1 and 10, 2, oh, sorry. I'm thinking way too fast. Let me slow myself down. 1 and 20, 2 and 10, 4 and 5. Now, I know one of these pairs of numbers, one of the numbers will be positive and one of them will be negative because I already did that. Our goal is to get a positive 1. There's no way it's going to happen with the 1 and the 20 and the 2 and the 10. My only options are 4 and 5. Now, if you notice, since we want positive 1, the only way I can get positive 1 is -4 plus 5, which gives me positive 1. So I know the 4 is the minus, and the 5 is the positive. And there you go. There's your answer. Okay? So what I'm going to do now is I'm just going to go ahead and just do a bunch of different examples here. And then we're going to get a little bit more difficult. And it's really not all that bad. Okay? So here's another one here. Let's try a to the second minus 3a minus 28. Okay? So it fits our mold. Trinomial with a 1 out front in front of the squared term. Now, I'm going to write the multiplication of two binomials. I put an A and an A. I always copy the first sign down. I just drop it straight down. My first number is negative. My answer is negative. Therefore, my second sign has to be positive. If you ever get confused, all you got to do is just write out this little chart that I'm writing on the right-hand side here. Plus, 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 minus, 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 plus, minus, oops. And minus, minus, plus. Like, you can always write this little chart down, okay? And like I said, your first number is negative. Your answer is negative, so that's going to be row 3. So negative times a positive equals a negative. So that's the beauty of this. The signs are done. Don't switch them. Let's write out the factors of 28. I think personally, writing out the factors of 28, that's the hard part, because you got to remember all those numbers that multiply to give you 28. So we have, give myself some space here. We have 1 and 28. We have 2 and 14. We have, does 3 work? Nope, 3 doesn't work. Does 4 work? I think it's 4 and 7. I think 4 and 7. And I think that's it, because if you notice, if I keep going, I know 5 doesn't work. I know 6 doesn't work. 7, well, that's going to be 7 times 4. So you notice I start to repeat myself. So we're going to stop here at 4 and 7. I know one of the numbers is positive, one is negative, and I got to get negative 3 as a result. The only way that's going to happen is plus 4 minus 7 equals negative 3. So I put a little block around that. And I'm just going to go ahead and write my answer out. 4 is positive, 7 is negative. And there you go. And here's the great part about this. You might be sitting there asking yourselves, well, how do you check just to make sure you're actually correct? Well, all you got to do is take your answer and distribute. A times A is A squared. A times 4 is plus 4A. So let me just erase. Underline. Negative 7 times A is negative 7A. Negative 7 times positive 4 is going to be negative 28. And when I combine everything, I get A squared minus 3A minus 28, which is the original problem. Okay? So you can always check yourself just by multiplying. Now, sometimes I may try to be clever and do something like this. Okay, I may try to write something like this. And this is where we need to be careful. Because if you look at this problem compared to all the other ones, right there is my x squared term. And the beginning of this chapter, or the beginning of this section, is factoring polynomials of the form x squared plus bx plus c. In other words, notice this is written in descending degree. The highest degree is always written first, and then it's written in descending order. So the first thing I'm going to do here is I'm going to rewrite my problem. I'm going to put x to the second first, plus 7x second, and then plus 6 third. Now, it looks just like any other problem. So that's one way that I can kind of make this a little bit more challenging, is I can just switch up the order. But all that means, you just got to take your time. That's it. So let's write the multiplication of two binomials underneath. Copy down the first sign. Obviously, the second sign has to be a positive because my 6 is positive. I write out the factors of 6, and I know they got to combine to give me 7, and both numbers are going to be positive, and that only occurs with plus 1 and plus 6. So plus 1 and plus 6. There we go. All right. Now, if you just kind of follow this technique, it really doesn't matter what problem I give you. It really doesn't. as long as you understand the technique. So watch this. This is going to look difficult, but in reality, it's actually very simple, okay? So we have m to the second plus 6 times m times n plus n to the second. Now, the only thing you need to ask yourself, is this in the form x squared plus bx plus c? In other words, this first term has to be raised to the second power with a 1 out front. And the answer to that question for our problem is absolutely. All right? The m is out front, and it's raised to the first power, or I'm sorry, it's raised to the second power with a 1 out front. So we fit the mold. So watch what happens. I'm gonna write the multiplication of two binomials. That's what I have here. Okay? Now the next thing I'm gonna do, excuse me, is I'm gonna write a plus and a plus because those are my signs. Now, there's also another thing I need to worry about, and that's this on the very end. So I know the last things I multiply, in other words, the last things I need to multiply here and here has to give me n to the second power. So I'm going to put an n and an n. The question becomes, what are those numbers in front of the letter n? So the only thing that we have to do is check ourselves. Notice that's going to be a number 1. So I'm going to write out the factors of 1. And the factors of 1 are just 1 times 1. That's it. Now, the question now becomes, since both of these are positive, does it equal 6? And the answer is no. So anytime you run into a situation where you cannot factor this problem or things just don't add up for you, we call that prime. And prime is just a very fancy one word for cannot be factored. That's it. Okay? So this is a situation where it looked really confusing, but if you break it down into its fundamental steps, not only do you get everything that you need, but you can also determine, can this be factored or not? In this case, it couldn't. Now, let's look at another one, just like this, where it can be factored, okay? So how about x squared plus 15xy plus 36y to the second? My approach doesn't change. I'm going to write the multiplication of two binomials. I copy down the first sign. Since my last term is positive, this sign has to also be positive, because a positive times a positive is another positive. Now, let's go ahead and let's write out all the factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, 7 doesn't work, 8 doesn't work, 9 and 4 work, but you already have 9 and 4 right there. So I can go ahead and stop here. Now, both of these numbers are going to be positive because I've already done the signs. And we know we need to combine to give us 15. Notice I really don't care about the variables right now. What I'm really concerned with, what's the number, okay? So plus 1 plus 36 is positive 37. Too large. Plus 2 plus 18, well, that's going to be plus 20. Too large. Plus 3 plus 12, well, that equals 15. So I know the numbers are going to be 3 and 12. The only thing that I also need to include is that y to the second power. Come on, where's my mouse? There it is. So what I'm going to do is write a y and a y. Now, if you don't believe me, check. X times x, x squared. X times 12 plus 12xy. Now, 3y times x is plus 3xy. Remember, order doesn't matter when you're multiplying. And then 3y times 12y is going to be plus 36y to the second power. And when you combine everything, notice that's exactly what you get. Okay? So, I hope this is making sense. The only way that this becomes easier is by practice. That's it. Like, you got to do a bunch of these. Okay? And I wish there was like just this easy, simple way. This is what you do and you'll be fine. My thing, practice. And to be honest with you, know these steps right here. Know these steps. If you can recognize this, everything's going to be fine. All right? So I will see you in the next video, which is factoring trinomials again. However, there is something different. So I'll show you that in the next video.